Ice ages, or glacial periods, are long periods of time characterized by extensive glaciation on Earth's surface. They are caused by a combination of various factors, including astronomical, geological, and atmospheric processes. The primary cause of ice ages is believed to be variations in Earth's orbit around the Sun, known as Milankovitch cycles. Milankovitch cycles refer to changes in three key parameters of Earth's orbit: eccentricity, axial tilt, obliquity, and precession. These cycles occur over long periods of time and affect the amount and distribution of solar energy reaching Earth's surface. The eccentricity cycle involves changes in the shape of Earth's orbit from more circular to more elliptical over a period of approximately 100,000 years. The obliquity cycle relates to changes in Earth's axial tilt, which oscillates between about 22.1 and 24.5 degrees over a cycle of roughly 41,000 years. The precession cycle involves the wobbling motion of Earth's axis, resulting in changes in the orientation of the axis over a period of about 26,000 years. These orbital variations affect the distribution of solar radiation received by Earth's surface. For instance, during certain phases of the Milankovitch cycles, the amount of solar energy reaching high latitudes, such as the polar regions, decreases. This reduction in solar energy contributes to the cooling of those regions, allowing snow and ice to accumulate and initiate the formation of glaciers. As the ice sheets expand, they reflect more sunlight back into space, further reducing the amount of solar energy absorbed by Earth's surface and leading to a positive feedback loop that amplifies the cooling. While Milankovitch cycles provide the underlying trigger for ice ages, other factors can influence their intensity and duration. Atmospheric greenhouse gas concentrations play a significant role in regulating Earth's climate. Changes in the concentrations of greenhouse gases, particularly carbon dioxide and methane, can affect the overall temperature balance by enhancing or reducing the greenhouse effect. During ice ages, lower levels of greenhouse gases in the atmosphere contribute to additional cooling, reinforcing the glacial conditions. It's important to note that ice ages are complex phenomena influenced by multiple interacting factors. The precise causes and mechanisms are still subjects of ongoing scientific research and modeling, but the Milankovitch cycles and greenhouse gas concentrations are considered to be the primary drivers behind the onset and termination of ice ages.